Calculate the cube root of 125 plus square root of 81. So we know, looking at this example here, we need to work out each individually. So the cube root of 125 is 5, right, plus the square root of 81 is 9. Right, there's nothing further we can do with this. So we say equals to 5 plus 9 is 14. Now before we move on to the next one, it's good practice for you to know from 1 all the way to 12. What I'm saying is 1 times 1, 2 times 2, the square of it, moving forward. And like 12 times 12 is 144. And to also know the square root of it. So we're saying 144, the square root of 144 is 12, because you know it both ways. It's good practice, so it speeds up your process in terms of the exams. When it comes to the cube roots, it's the same thing, and cubing a number, like 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and you should know it, the reverse of it, where the cube root of 27 is 3. And this would actually speed up your process in terms of the examination. In approaching this question here, our focus would be on the brackets part, but there's 2 sets of brackets in this particular question. And keep in mind that we have to focus on Bodmas as well with this, because there is a division here. So we'll do the brackets first, and then we'll do the division. So we'll work this part of the question first, because there is decimals there. Right, and let's simplify that. Let's rewrite our question and focus on the decimal part, which is within the bracket. Right, and focusing on this, we'd get the answer of 2. If you use a calculator, you find that that would give you your answer. Then looking at the next part, which is the part here in the brackets, we'd combine that and know that is 3 and 1/3, because adding these two numbers here is 3 over 1 plus that 1 over 3 will give you 3 and 1/3. Now remember that this is a mixed fraction, and take note of that. And working with mixed fractions, we generally like to change them into improper fraction. So how do we do this? We take the 3, multiply by the 3, and add the 1. So we have the 3 times this 3, and we add the 1. So our mixed fraction will be changed into an improper fraction. So it would be 10 over 3. Right, divided by 2. So now we can work with this here. Remember that although this is 12, this is actually 12 over 1. Right, so now we can see that fractions are being multiplied here. So looking at this here, we can say 3 goes here 1 time, and 3 goes here 4 times. A process of cancellation. So now we have 4 times 10. So our answer will be 40 divided by 2. And our final answer will be 20. Now keep in mind, obviously you need to put your steps with the equals to sign, right, as you show your steps. And make sure in maths you always show steps, and that will be your final answer. Now working with HCF and LCM, we generally use what is known as the ladder method, or some people call it the fishbone method. It works out the same thing. So initially we look at 2 steps here. There's 12, 42 and 27, that's the numbers, and then thereafter we're going to focus on the letters. Right, so remember we have to take into account both sides. There's the numbers here and letters. Right, so let's start off first by what we know, which is the numbers. So we have 12, right, we have 42, and we have 27. Right, remember when dealing with this, we need to focus on prime numbers. Right, and our lowest prime number is 2. So 2 goes there 6 times. 2 again. Always go with the lowest prime numbers, and that will be 3. Then we have 3, and we always end off with 1. Right, the next one is, we will use 2. This will be 21. We can't use 2 here now, so we'll use 3, and it goes 7 times there, and 7, and we end off with 1. Right, and the third one here is, we can't use 2, so we'll use 3. right? Because this is an odd number. So we have 9, we have 3 again. It's important that you know your timetables, so it will help you to speed up this process. Thereafter, we write down what we have in expanded form. So we'll say 12 is equal to, right, it will be 2 times 2 times 3, right? Then we have 42 is equal to, it will be 2 times 3. It's important to put it in its columns so you have an idea, times 7. Now I'm looking at the general 3's here, so I know that I'll be having 3's here, so that's why I separated this 7, right? Then we come to the 27, so I'll cater for the columns. So I put 3 here, times 3 times 3. Now you notice I have them in sets here. So by looking at it, it must be common when you're dealing with HCF. It must be common to, now you find this 2 is common to these two numbers, but it's not to that. So we'll take the one that is common to all three, and that is our 3 here. So basically the HCF in terms of the numbers so far will be 3. But there's a second part here, which is the letters. So our first one would be the x squared for the 12. Right, I'll write down the 12 here so you know why we are choosing that, but remember our focus will be on the letters. So we have the 42, which is x cubed y squared, and then we have the 27xy. So we will write it down this in expanded form. So we have x times y. Then here we have x times x times x again times y times y. Okay, and then we have x times y. Forgive me for this part here, the screen was not catering for space, but you understand that all this here is in one example. Now remember, we're only going to look for the one where is common to all. And if you notice here, there's an x common here, and x, right? So this will be the one I will circle. And the next one will be, there's an x here, but there's no x here, another x here. So we're leaving the x's out. So let's look at the y. There's one y here, there's another y here, in the second one, and there's a third y. So we'll obviously take that y section there. Forgive me for the way it's done. So basically we can see that x and y is common. So our answer will be x, y. So this will therefore become our highest common factor for this particular example. Okay, when dealing with a question like this, all we just know is we read the question and write down the relevant information given to us, and look at keywords will indicate as to what's required of us. So a car travels for 300 kilometers. Now we know that this is distance, which is 300 kilometers. Right, then we have the speed that's given to us in this question, and it's 65 kilometers per hour, right? And then lastly we have time. Now time is not given to us, but by the words how long, that will tell us that what's required of us is time. Now time will obviously be in hours, because we notice that the kilometers will cancel off and we'll end up time in hours. So if you're unsure about how to use the formula, then we generally use what is known as the triangle method to help us remember. All you got to remember is that speed is equal to distance over time. Right, and this line here in the middle here is indicating to us that's the division sign, and you can put a multiplication sign here to tell you that distance is equal to speed times time. And in this particular instance, for this example, we want the time. So let's look at the triangle. It shows us the time is equal to distance over speed. So let's write this down. Time is equal to distance over speed. So let's substitute our information. We have 300 kilometer over the speed is 65 kilometer per hour, and our final answer will be in hours because the kilometers will cancel itself out. And this brings us to a final answer of 4 3.615 hours. Now I wrote this in 3 decimal place because they're not indicating in the question how many places to put it. It depends on the examiner what they require, and then you follow according to the amount of decimal places they indicate.